Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about some of the important NCERT exemplar questions of work energy chapter. This is mainly for class 9 students. Okay, so this work energy, the whole chapter revision once we did in the last week, right? So today we are going to discuss some of the exemplar questions from your NCERT book. Okay, so first question is, Avinash can run with a speed of 8 meter per second against the frictional force of 10 Newton, and Kapil can move with a speed of 3 meter per second against the frictional force of 25 Newton. Who is more powerful and why? See here, Avinash can run. First one, Avinash. First about Avinash we are writing. Okay, so with a speed of, so velocity is given as 8 meter per second. And against a frictional force of 10 Newton. So force is given as 10 Newton. Then Kapil can move with a speed of, Kapil can move with a speed of 3 meter per second with a frictional force of 25 Newton. Okay, who is more powerful and why? So power we should find out. If F and we know power, how we can find out? Rate of work done, that is power, right? W by T. But W equals F into S divided by T. What is S by T? That is velocity. So F into V. So here what is power of Avinash? That is equal to 10 into 8, that is 80 watt. And here power of Kapil is equal to 25 into 3, that is 75 watt. So who is more powerful? Avinash is more powerful. Okay, so next is, can any object have mechanical energy even if its momentum is zero? Explain. See, momentum is zero and mechanical energy is existing. In like that, any object, whether it can be, that is the question. Yes, it can be. Suppose if I am throwing some object, initial velocity I am throwing. Throwing means initial velocity will be there, but final velocity will be equal to 0. While I am throwing with a velocity, u is existing. At the maximum height, what will happen? Final velocity will become equal to 0. If final velocity is 0, what will be the kinetic energy? Kinetic energy will be equal to 0. So kinetic energy is 0, so momentum is 0. But potential energy is there due to height, right? So mechanical energy is existing, it's potential energy, but since velocity is equal to 0, momentum will be equal to 0. Therefore, momentum is, if momentum is 0 also, this kinetic energy is existing, that is mechanical energy is existing. Okay. Next is, can any object have momentum even if kinetic energy is 0? See, kinetic energy is 0 means velocity should exist, right? So if mv equals 0, half mv square also will be equal to 0, right? If p equals mv and as that is equal to 0 means kinetic energy, obviously that will be equal to 0. Okay, then kinetic energy will be equal to 0. So if momentum 0, kinetic energy won't be existing. If momentum is 0, mechanical energy will be existing over there. Okay, so the next question is, the power of a motor pump is 2 kilowatt. How much water per minute the pump can raise to a height of 10 meter? So power is given as 2 kilowatt. We should find out the potential energy. How much water per minute the pump can raise to a height of 10 meter. So power is given as 2 kilowatt. And next what is given? How much water per minute can the pump can raise to a height of 10 meter. How much water to a time interval is given as per minute? That is 60 seconds, and to a height of 10 meter. H is given as 10 meter. Okay, how much water we should find out? How we can find out the mass of water we should find out? Okay, P, we know that work done by time will be equal to P. It is going to a height of h. So what will be the work done? Work done will be equal to mgh divided by T equals P. And so here what will be m? M will be equal to Pt divided by Gh, mass of water. P is given as 2 kilowatt. So convert it into watt, and time is 60 seconds, G is 10, height is 10. So here we will get it as 110 will be existing and 21200. That much of kilogram. Okay, clear? This is how we will be finding out the mass of water. How much of water will be existing there in the tank. That only it is asked. So power is given, time and h. Okay, height also given. So you can find out the value of mass of water. Next is the weight of a person on a planet A is about half that on the earth. He can jump up to 0.4 meter height on the surface of earth. How high he can jump on the planet A? Okay. Here the weight of a person on a planet A is about half that on earth. So here between planet and earth. Okay, weight of a person on planet, I am writing it as WP. That will be equal to half that on earth, half of weight on earth. So weight on earth, I am giving it as WE. Okay, then he can jump up to 0.4 meter height on the surface of earth. Okay, he can jump up to a height of 0.4 meter on the surface of earth. How high he can jump on the planet A? Okay, so here planet, what will be the height? How we can find out this one? See here, we know that energy is a conserved quantity. That means whether it is in earth or it is in planet, energy will be conserved one. Another planet, right? So it is here using conservation of energy, m G1 H1 will be, or Gp Hp will be equal to m G mge he. Right. So here we can write it as m and m will get cancelled. So or we can write mg as weight. Weight of planet into height of planet will be equal to weight of earth into height of earth, because weight equals mg is the formula. Right. So here Wp equals half into We into Hp equals weight of earth into He. We already know it as 0.4. So We, W will get cancelled. So here 2 into 0.4, the answer will be 0.8 meter. Okay, like this we should do. Next is the velocity of a body moving in a straight line is increased by applying a constant force F for some distance in the direction of motion. Prove that the increase in the kinetic energy of the body is equal to the work done by the force on the body. Okay, so here we should prove that increase in kinetic energy of a body is equal to the work done. Change this increase in kinetic energy. Increase in kinetic energy equals work done. Like that we should prove. Okay, so for that in the question it is given velocity of a body is moving in a straight line increased by applying a constant force F for some distance in the direction of motion. Constant force means acceleration will be constant. F is equal to ma. Right. So constant force means it is having constant acceleration. So the velocity is increasing uniformly. So we are getting an acceleration over there. Okay. So increase in kinetic energy. here we can find out the work done. What is the formula for finding out the work done? Force into displacement. So how we can find out the displacement? S is equal to how, if the velocity is increasing from u to v, what will be the velocity? This v square minus u square equals 2as. So from here s is equal to v square minus u square divided by 2a. So here we can apply m a dot v square minus u square divided by 2a. Correct? Then a and a will get cancelled. Here we will get it as mv square minus mu square divided by 2. That means it is equal to half mv square minus half mu square. What is this? This is equal to change in kinetic energy. Therefore, work done will be equal to increase in kinetic energy, because for the kinetic energy nothing is given. So you can try in this. So actually this is how we will be finding out the equation of kinetic energy, derivation. So that one in a different way it is asked. Okay. So that one you should identify while reading the question. Is it possible that an object is in a state of accelerated motion due to external force acting on it, but no work is being done by the force? Explain it with an example. Okay, so whether an object is in a state of accelerated motion due to external force, but no work is done on it. So when even if we are doing some work, physically we are doing some work, when and all we will say work done will be equal to 0 if there is no displacement. See, I am applying force on the wall. It is not moving. I am applying force, but it is not moving. Since it is not moving, displacement is equal to 0. Work done will be equal to 0. Otherwise, a person with some weight on his head walking on a parallel road, on a straight road, while he is traveling, weight mg is acting downwards. He is moving in a straight road. So mg and displacement both are perpendicular to each other. Okay, mg is acting downwards, displacement is happening in this direction, so work done will be equal to 0. And if, see, in a circular motion, centripetal force is acting towards the center, velocity is towards the tangent. So what will be this angle? This will be equal to 0. Since it is 90 degree, work done will be equal to 0. So any one of the example you can give. Okay. Next is, a ball is dropped from a height of 10 meter. If the energy of the ball reduces by 40% after striking the ground, how much high can the ball bounce back? Okay, so 40% of the energy is it's losing. So how much it will be there with the ball? 60% is with the ball. So what was the initial, that is, if initially it was 10 meter. Okay, 10 meter was there. Now how we can find out what will be the weight? So it was from a height of 10 meter, and while it is falling down, it is losing 40%. So now it has 60% with it. So how much high it will be going? 60% of 10 meter height it will be going. That means 60 by 100. So here we will get it as 6 meters. Okay, clear? Then next is, a light object and a heavy object have same momentum. Find out the ratio of their kinetic energy. Which one has larger kinetic energy? Momentum is same. Okay. So kinetic energy, which one has larger kinetic energy, it is asked. Momentum is same. So how we can find out? We should give an equation connecting kinetic energy and momentum. What is the relation connecting kinetic energy and momentum? Kinetic energy, we know it is half mv square. Momentum, we know it is m square v square. So comparing, mv is momentum. So comparing these two equations, I can change kinetic energy in terms of P like this. If I am multiplying m on both the sides, it will become m square divided by m. What is m square v square? It will be p square by 2m. So kinetic energy we got it as p square by 2m. Kinetic energy equals p square by 2m. Now both the objects are having same momentum. Momentum is same. So now kinetic energy, find out the ratio of the kinetic energy. Which one has larger kinetic energy? So momentum is same means kinetic energy is proportional to 1 by m. So which is having less mass. Mass is less. If m1 is less than m2, its kinetic energy will be greater than second one. Okay, so which one has smaller mass will be having more kinetic energy. So this equation you should keep in mind. Kinetic energy equals p square by 2m. Clear? So next one is a girl having mass of 35 kg sits on a trolley of mass 5 kg. The trolley is given an initial velocity of 4 meter per second by applying a force. The trolley comes to rest after traveling a distance of 16 meter. How much work is done on the trolley and how much work is done by the girl? So here from the question it is clear that, see, trolley is moving. Trolley and the girl is we can consider as a single mass. Okay, so a girl having mass 35 kg sits on the trolley of mass 5 kg. So trolley and the girl together we can consider as a single system. Trolley is given an initial velocity of 4 meter per second. Trolley comes to rest after traveling a distance of 16 meter. So who is doing work here? How much work is done on the trolley? How much work is done by the girl? What will be the work done by the girl? Work done by the girl will be equal to 0. What is the reason? This is trolley and this is girl. Okay, trolley, we are applying a force to the trolley, right? So girl has a force acting downwards and it is moving in this direction. So what will be the angle? 90 degree. So work done by the girl will be equal to 0. That answer already you are getting. Okay, so the rest of the things. Now what is the total weight of the trolley now? Girl and the trolley weight. So together what is the total mass of the system is 35 plus 5, that is 40 kg. Now it is given an initial velocity of 4 meter per second. So u equals 4 meter per second. The trolley comes to rest. So final velocity is equal to 0 and traveling a distance of 16 meter. So s is given as 16 meter. How we can find out the work done by the trolley? Work done equals force into displacement. Okay, so mass is given but we don't have A with us. So how we can, F is equal to ma into S. So first our aim is to find out A. V square minus U square equals 2AS. Okay, A will be equal to V square minus U square divided by 2S. Substituting here, work done will be equal to m into v square minus u square divided by 2s into s. S and s will get cancelled. So here we will get it as half m v square minus half m u square. Here tell me, half m into, what is m is 40 into v square minus 16, 4 square. So here you will get 320 joule. Okay, negative 320 joule minus 320 joule will be the work done on the trolley, and the work done by the girl will be equal to 0. Okay, so these are some of the questions from your NCERT exemplar questions only. So I think it will be useful for you to thorough with your subject. Okay, the concept and all will be clear if you are doing more and more problems. Okay, so if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.